The next speaker up is somebody quite extraordinary. And not just because of the reason that she left Tartu, my hometown, in 1998, and just came back 3 days ago. But she does something which most of us most likely don't even think of. She, namely, works at a company who thinks how to mine water on the moon. Please, ladies and gentlemen, welcome Erika Ilves on the stage. And when she's coming, we spent a wonderful, yes, you need a clicker, yes. We just spent a wonderful weekend mentoring Garage 48 Space Tech. And yeah, thank you for coming again.
It was wonderful. I didn't know we had so many space startup ideas in Estonia, so I was getting a great surprise. Slides would be great. Okay. So, space is the new internet, declared Newsweek last year, after interviewing actually a fellow Estonian, Steve Jurvetson, who also happens to be a VC in the Valley, and his firm has invested in SpaceX and Planet Labs and so on. 10 years ago, we had about 100 commercial space companies. That number today is 1,000. 2.3 billion was invested last year. That's more than has been invested in space startups in the last 15 years. 8 exits in our sector since 2000. We have 1 unicorn, SpaceX. Planet Labs could be next one up. And some people say trillionaires would be made in space. What's going on there? Should you get in on the action? As Spock once said, insufficient facts always invite danger, so my job today is to give you the facts so you can make up your own mind. So, let's start with the basics. Space is a very big place. It's not a black abstraction above your head. So if you're an entrepreneur or an investor, you're thinking about this narrow patch between the Earth-Moon system and Mars. Same thing, Earth-centric view. So places of interest. We've got low Earth orbit starting at about 200 kilometers, lots of action there. Geostationary orbit at about 35,000 kilometers, very interesting place, lots of action and money made there. The moon is 400,000 kilometers away, and Mars on a good day is 78 million kilometers away. Just as an orientation, what have we got there so far? Permanent population, 6 people working on the International Space Station. It is 400 kilometers away. That's basically the distance between here and Stockholm. Since the beginning of the space age, more people, or actually there are more people in this room that have been to space, and most of them have not made it past Stockholm. We've had 24 lucky American guys who made it all the way to the moon, but that's pretty much it. We have launched 8,000 man-made objects. Most of it is now trash, orbiting around our lovely planet. In terms of active systems, what we've got right now is 1,400 satellites in Earth orbit. We've got 2 active robots on Mars and half a live robot on the moon. So now let's take an entrepreneur or investor perspective. The entrepreneurial zone can be divided into 3 subzones. The first one, the perfectly sane grown-up zone, that's basically all the action in Earth orbit. That's where space startups with actual revenues from non-imaginary customers live, okay? The next one is, that basically goes from there all the way to the moon and near-Earth asteroids. That's the certifiably insane zone. That's where I live, so just bear that in mind as you listen to me. And from there onwards is just the totally bonkers zone. So we're going to walk you through, what's real, what's potential and theoretical, and then we can talk about what could happen in the future. Space business today can be reduced to satellites, rockets, and stuff satellites do in space. That's it. There's nothing more to it in terms of the actual scalable big business. As you can see, satellite services is the main event. It's $120 billion. And it's pretty much divided into stuff that goes on in low Earth orbit and stuff that goes on in geostationary orbit. We'll start with GEO. GeoBirds are the most amazing, beautiful things. If you've seen one in the Bay, I still dream of those. It's about they can be as heavy as 5,000 tons. They're essentially souped-up antennas that we fling so high up that they fall around Earth at the same speed as the Earth rotates, so they stay in the same space. What do? They relay satellite TV signals, satellite radio, and comms. Now, we launch about 25 of these, and it costs $250 million to build, launch, and insure one of these, which basically means they're a little bit outside of the range of your grandma's startup. However, the birds that fly much lower, the non-GeoBirds, that's where all the startup action is. With cheaper and smaller electronics, now a satellite can be basically a souped-up iPhone. They can get CubeSats are pretty small, 10 by 10 by 10 centimeters. They're a little bit, over 1 kilogram in weight. And why would you want to, well, actually, if you wanted an off-the-shelf kit, you could get one now, a CubeSat, for less than $15,000. So why should you get one or 50 of these? The answer is all the sensors you can put on them. There are many types of sensors. I'll just focus on the one that every one of you carries in their pockets. That's camera. So this is a picture Planet Labs took just 2 weeks ago in Egypt. It's fire in the agricultural production site. Who would want to have a picture like that? In the old days, when the pictures, satellite imagery like this cost many thousands of dollars, sometimes in tens and 20s, the early adopters were, unsurprisingly, the world intelligence agencies and the military. The early commercial use was all about tradable intel. We've had hedge fund firms in the US pay startups to look at satellite images of parking lots of big box retailers in the US. And the trick there is, if you track the car parking lot and the movements there, you could predict the foot traffic, and basically you get a sense of the performance ahead of the company announcements. But today, as the price has come down, pretty much everybody wants these pictures. From agricultural producers who want to track the health of their crops, all the way to tax authorities who want to track your unauthorized home extensions. This is a real thing, it's being used for that, so just beware. Here's a picture of a solar power plant in South Africa. If you've invested in one of these, you'd be very interested in knowing how fast it gets completed. If you're relying on energy from one of these, again, you'd be very interested to know about the progress of this. In the old days, like 2 years ago, we used to have people manually look at the images and literally count the cars in the parking lot. Today, thank God, with advances in machine learning, we can automate a lot of the pattern recognition. So you can imagine that it becomes much, much easier to process heaps and heaps of data, so the cost of the insight is dropping. The ultimate end game here is to have global, persistent, real-time coverage of Earth. That's the nirvana we're all working towards. We're not there yet, but I think with many constellations coming online, we might get there in about 2 to 3 years. So definitely that's the place where you want to be. There's another option, what you could do with these satellites. You could create a constellation. For example, OneWeb is planning to put 700 of these in low Earth orbit to create global access to internet. Now, this one is a $3 billion investment, so again, a little bit outside of your grandma's startup. I don't know why. My grandma did not start a startup, but for some reason. Rockets. We need rockets to get the birds up. That is our Achilles heel in the sector. The cheapest rocket today is $62 million. That's the latest, cheapest SpaceX wonder. Of course, you can share the rides, but then you don't control the timing, you don't control the orbital placement, and I personally find it shocking that our launch rate, how many launches we've had last year? Just a wild guess, anyone? 86. 86 launches. Now, these are not the 86 rides you could have shared. Most of these launches are government launches, so if you wanted to go to LEO, you had 14 slots last year. It's scandalous. If you wanted to send cargo, a kilogram of anything from Tallinn to Stockholm, it would cost you $3 per kilogram, I checked. If you wanted to do the same, but by rocket or with Stockholm in space, it will cost you 1,000 times more, or $3,000. The reason for that is, we reuse the airplanes, we treat our rockets as condoms, use once, throw away. And there are many people working on this. SpaceX is working on at least making some bits of the rockets reusable. If all goes well, in several years' time, we may get to 1,100 kilograms dollars per kilo to LEO. Good progress, but still not quite $3. We've got many companies working on fully reusable systems, reaction engines and Blue Origin, but it takes billions of dollars and it takes a long time. But at least there is hope in terms of frequency. There's enough in the pipeline to increase the launch frequency. So in terms of actual existing real space, I'd say where cheaper rockets meet cheaper small sats that generate heaps of data that can then be processed with machine learning, that is where space is the new internet. It's not going to make you a trillionaire, though. And for that, we need to talk about potentials. So here are just some examples of businesses that could become a reality. I'll just walk through them one by one just to give you a sense of what could be possible. I'll start with the least glamorous. We have all this trash in orbit. We need a space janitor. Frankly, it's quite a ticking time bomb. A cascade of collisions between larger objects could easily make the entire Earth orbit, or at least bands of the orbit, unusable. Everybody agrees it's a problem. There are teams working on solutions. The big, hairy question that we have not answered yet is who is going to pay for this cleanup? Microgravity research could be amazing secret source for invention. When you remove gravity as the dominant force, you have other forces like capillary surface tension and capillary forces that become dominant. And pretty much everything from crystals, materials, genes, plants, human bodies, they all behave differently in microgravity. And that can give lots of ideas for new products. We had the same experience when we started doing very, very cold chambers. That led to quite a few inventions. Today, International Space Station is one of our major research platforms. We do 30 to 40 experiments per year. Most of them, though, are government and academia, so not too many commercial experiments. But it is not inconceivable that one day we will have commercial labs up there doing commercial experiments at scale, so that could be very exciting. Mining. We've got all this orbital junk, we've got the moon, we've got 11,000 near-Earth asteroids, super rich in resources. It's all wonderful. The thing to understand about space mining, it is highly unlikely we will be bringing any of it back to Earth. It will pretty much always be cheaper to either recycle or mine the seabed. The reason why we want to mine the moon and asteroids and even orbital junk is because we want to build things in space. So in theory, we do have trillions of dollars worth of assets flying around in the neighborhood. However, in practice, the size of the space mining sector depends completely on what you're going to be using the resources for. So here is one use, fuel. We don't have any dead plants or animals in space, so we're using water. Break water into oxygen and hydrogen, you got your oxidizer and fuel. If we could have fuel stations in space, something cool would happen. We could have space trucks. I never thought I'll grow up and I'll be excited about space trucks, but I really am. And the reason why I am is because imagine what we could do now. We could use our expensive rockets to get to LEO, and then from LEO onwards, we would have completely reusable, cheaper mode of transport, just like on Earth. Now, if you can move around cheaply between the moon, near asteroids, and the orbit, we can start building things out of the materials. We could have factories that do, here you can see an orbital factory doing solar reflectors, but we could do solar panels, we could do structures, we could graduate to building satellites and stations. Very exciting. We could build and robotically put together solar power stations in orbit. First, we could use them to power our satellites and stations. But then we could start doing cooler things. On Earth, data centers, are hungry beasts. They consume 10% of global electricity. And I think the amount is predicted that it's going to treble by 2020. Now, if we took these up and put them into geostationary orbit, first of all, we can have access to abundant energy without environmental footprint, no real estate cost. Microgravity will keep the hard drive spinning longer without resistance. And, interestingly, you could bypass the internet and beam data securely directly to mobile devices. So, for people who are very keen on security of their data, that could be an interesting solution. Now, it gets wilder. Fasten your seatbelts. If we really get good at generating solar power in space, we could build a network of solar power stations and start beaming terawatts of power down to Earth. Now, a network of solar power stations basically means that we could avoid night-day cycles, so you have 24-hour availability of power. You get more power in space because we don't have, atmospheric attenuation. And it could be quite amazing. Another potential, let's talk humans. Today, I guess it's on many people's bucket lists going to space. Today, you don't have that many options, frankly, unless you train as an astronaut. Maybe in a couple of years, you could go with Virgin Galactic on our suborbital joyride. I think when people get excited about going to space with Virgin, just know that it's a couple of hours and you're done. You're not going to visit anybody in space. You may be able to do it much cheaper with X-Core for $150,000. Maybe one day Bigelow will put an orbital hotel. That would be nice. In the past, it used to be possible to go to the International Space Station for $20 to $40 million. So not a mass market value proposition. But if you are willing to wait for a decade or two, you might, for a bargain price of $500,000, go on a one-way trip to Mars with Elon Musk. That's the promise. You're not going to be going on any one-way trips before we figure out how to do closed-loop life support systems. Agriculture is part of it, becomes a critical need. Right now, we have major research efforts going on. We've grown our first crop of lettuce, and astronauts ate it. Nobody called in sick, as far as we know. And you can look at it and think, well, okay, this is just pure space R&D. I know, what does that have to do with startups? But actually, as is often with space tech, while you're developing something for in-space use, there are many commercial applications on Earth. So, for example, ESA's Melissa project has led to a CO2 sensor that is now used in sparkling wine. Think about that next time you cheer. Space health. Well, okay, this one, it's really not trivial to keep a human alive and well outside of the Earth's magnetosphere and atmosphere. We need spacesuits, we need shielding against radiation, we need to figure out how to stop bones from losing density, muscles from losing tone. Frankly, it's a very, very long, liquid flows, it's a very long list of problems that we need to solve. The interesting part about all the symptoms not all the symptoms, but some of the symptoms that we get in space is that they are quite similar to the symptoms of aging on Earth. Just in space, they happen faster. So there may be a possibility that if you figure something out in the space context, you may have some form of market on Earth. So I've gone through most of the potentials, at least the big ones. There could be businesses in theory. In practice, it's very hard to raise money for these. Most of the teams that work on these potentials basically live off grants from space agencies, or then they try to find a way to commercialize some of the space tech that they're developing for other in-space applications or terrestrial applications. So all the potential bubbles that you see there, that's not where space is the new internet. It's more like space is the new infrastructure. And the new part is that it is 100 times harder than infrastructure on Earth because you don't have any existing markets to point to. couple of words, so these are kind of theoretical potentials. Now let me speculate a little bit in terms of what could happen in reality in the next 15 years. The saddest scenario is that nothing exciting really is going to happen, and some things are going to get worse. The International Space Station might very well end up at the bottom of the ocean in 10 years if the partners don't agree to extend the cooperation. Then we won't have anything, no microgravity research and all that. Satellites will keep growing. That's great. Launch rate will probably go up to 100, 120 per year. Maybe we'll get 500 people per year to do suborbital joyrides, but that would be $100 million niche, so a tiny little addition. So other than that, structurally, nothing, it's very plausible that nothing is going to change other than all the segments we've got today are going to just grow. Big new markets. Many people in our sector believe that there's only one way anything exciting will ever gonna happen in space. And that is launch costs miraculously will drop 10x, and then the highway to space will just open up. Now, sadly, we don't really have anything in the pipeline right now that could get us to $300 per kilogram to LEO in the next 10 to 15 years. So that's unlikely to happen. However, there are other ways for exciting things to happen. For example, if we cracked space mining, if we managed to jumpstart space mining, that would allow us to sidestep the expensive launch problem and start building things in space. Of course, it's difficult to raise money because you don't have any markets to point to. By the same token, it's difficult to get any business plans going, looking at developing the space tech for markets because you don't have any supply chain you can point to, so it's a chicken and egg problem. But people are pushing from both ends, and I do think there is a non-zero chance of success here, which is why I'm still on it. Also, microgravity research could lead to a discovery of some wonder material that could close the business case for a commercial lab in orbit. That could lead to tens, maybe even hundreds of people working in orbit. That could happen. Any of these could happen. There's another exciting possibility, and that it is not unrealistic to expect that after the International Space Station, we will have a global coalition of governments and companies to go to Mars, hopefully via the moon. That would accelerate all the potentials I talked about. That would accelerate it pretty much immediately. That would be great. And we would also have a revolution in space robotics because we're going to have to send an army of robots ahead of any human landings. Then we would also likely use the moon as our staging area as well as the technology test bed. I mean, that could be beautiful. And for argument's sake, I just picked up 2 black swans, killer asteroids, and aliens. Both actually could be good for business. If tomorrow we discovered a 10-kilometer asteroid on a collision course with Earth, or signs of technologically advanced civilization, then I think we're going to have a mobilization of resources for space that are just unprecedented in scale. I think Apollo might look like a little warm-up. So, should you invest in space? Should you start a space venture? Couple of words of national policy now that I'm back in Estonia. A small country like Estonia can become a giant in commercial space. I'm quite sure of this, not because I am a delusional patriot, but because it has been done. In 1985, Luxembourg, with no prior experience, decided to invest in Europe's first commercial satellite operator. Today, SES is a $2 billion business with 50 geostationary birds in orbit, buying up other businesses along the way. Luxembourg attracted many other satellite operators, and that's not even where the story ends. A couple of months ago, they decided to make a new bet, this time on space mining. So I think there's plenty of space to get creative here. If you are an investor, now, if you're looking for 10x returns and an exit in a couple of years, I've just wasted your time. Frankly, there are just much easier ways to make money on Earth. I wouldn't bother. If you want to sprinkle some of that space magic on your portfolio but don't want to lose your shirt, then this combination of small sats, data, machine learning, it's a very nice investable combo. Go for it. If you want to make a dent in the universe and can afford to wait 5 to 10 years, there are plenty of high-risk options that you can pick. I think the key challenge here is most business plans have amazing tech solutions to problems that you don't have customers to pay for them. So you'll have to get creative to help your portfolio companies. And yeah, I'll finish with words to potential founders of space ventures. First, a word of warning. Space bug is a serious lifelong condition. There is no cure, I promise. I have seen people in their 70s, they're still trying to launch a new rocket. It's quite impressive. If you want to build a small sat or start a downstream data processing company, go for it. You're on the right bandwagon. There are 250 investors await. It's great. Just go for it. If you're attracted, like some other people in this room, to any of these potentials, you need to know a dirty secret. It took some of us a very long time to learn this. You cannot get from A to B in a straight line. You're going to have many detours to take, and the key here is to make sure that your detour allows you to develop your space tech along the way. And I do really believe if you apply yourself, you can make it so, number one way or another. Thank you.
Thank you. Let's switch. Clicker for me, back for you. But you said you gave a wonderful general overview of what's happening in space tech. But what does your company do?
Space mining robotics. And just like I said, we started with a space mining company for the moon, focused on water, turning water into fuel and building gas stations. That is an $18 billion startup. Unsurprisingly, not very easy to raise $18 billion for a brand new company. So we decided to pivot. So now we're focusing just on the robotics part, trying to figure out how we could do swarm mining on the lunar surface, but using Earth and terrestrial clients as, to pay for the development. So we're on our way, but the way to the moon starts on Earth.
To summarize, let's bring some of those space tech things into Estonia and make us a little bit bigger than Luxembourg in the field.
Asteroids away? No.
Asteroids. Wonderful. Thank you very much. Give Erika a big applause. This was wonderful.